in this part of the video, I'm going to show you a couple of operator overloading. I'll pick one from each category. And the first one I pick is the assignment operator overloading. Let's take a look at this assignment operator overloading. And before we do anything, let's see why it's necessary. How about now if I comment out this assignment operator overloading? So I comment it out from the header file and the CPP file. So we don't have that assignment operator overloading anymore. And now let's come to the test file. So you see this test file, I did something very simple, the constructors, and here I'm trying to assign student 2 to student 1. And let's go ahead and build this program. So I'm trying to assign. It should compile fine because the compiler allows assignment operator to be used. But let's take a look at what happens when we try to run this program. You see it crash again. So if I take a look at the call stack, again you see this is the main function. Again we crash at the destructor. So if we take a look at the destructor and we are trying to delete some name that's not there. So now let's come back to the assignment operator here. So exactly what's happened when I try to do the assignment. Again, you have heard this before. The shallow copy get created. When I try to assign student 2 to student 1, it will do a field by field assignment of the data member for student 1. So you can imagine this way. I'm trying to draw the diagram with my mouse again. So this is student 1. So I'm going to call it S1, and this is student 2. This is student 2. This is S2. And in student 1, it has a pointer, and for the ID, and student 2, it has a pointer to the ID. In this case, student 2's pointer ID is pointing to a memory and contains Sally White actually. Okay. And now when I try to do the assignment, assign student 2 to student 1, so it will do this pointer assignment. So S1 will point to whatever here, and later on, when the lifetime of student 2 is over, the destructor gets invoked. So Sally got deallocated. When S1's lifetime is over, it's trying to invoke this destructor and try to deallocate this memory, which is already gone. That's where it crashed our code. So again, this problem is created by shallow copy. So we want to overload the assignment operator. The one the compiler gave us isn't good enough. What it does is just do a field by field copy, which is a shallow copy. So we want to teach this assignment operator how to behave when we are trying to do this object's assignment. So alright, now let's take a look at our data file. I'm going to put in this assignment operator overloading and come back and put it back in this assignment operator overloading. So let's take a look at the implementation. So if this is equal to pass in student object, I'm trying to compare address here. This is a pointer to the current object, and I take the address of the passed in object. If the address are the same, that means this is self-assignment. If it's self-assignment, we don't want to do anything. We just want to return this data, which is dereference this pointer. Else, we want to set name to student name, set PCC ID to this student PCC ID, and you will see this is essential. Assuming if we don't do this, if it's a self-assignment, we are trying to set a name with student name. Let's take a look at what's happening at the set name. It will say, oh, if you currently have a name, I'm going to delete it. Imagine this, for self-assignment, you're trying to first delete this memory, then try to allocate memory, and that will be disaster. So we need to first test if this is self-assignment. If it's the case, we don't do anything. We don't want to delete ourselves, then try to allocate memory. Alright, so essentially this assignment operator overloading just give you back a deep copy. And after we have this one, assignment operator overloading, if you go back to this code, the same code, and build, and start debugging, it's not complaining anymore. So this is called assignment operator overloading. You might be wondering where the syntax come from, why it looks like this way. So when we do S1, so how about I'm trying to draw something here. When we say S1, we're trying to assign S2 to S1. We're trying to do this. Actually, essentially, this is what's happening. So S1 dot operator assignment S2. This is what's really going on. So you take a look. So we invoke operator assignment, which is this function name, operator assignment. So it's just a function name, operator assignment, and pass in S2 as a parameter. So we invoke it on S1. So S1 is the left operand, and invoke this function, pass in S2. So, and also the reason this one returns something that's very similar to this parameter is we're trying to enable something called chained assignment. So if we have something look like this, because it's assignment operator, so you're going to evaluate this one first. Then if this only if this one returns something identical as a parameter list, we can pass in this one to S1.operator assignment. So that's why where this return type coming from. Alright, so that's assignment operator overloading. I overload assignment operator as a member function because it has to be this way, because assignment operator modifies the left operand, so it has to be a member function. Now let's take a look at this this operator overloading. It's the insertion operator for OStream. So first I'll go ahead and comment it out. So assuming we don't have this operator overloading, and I'm going to comment it out from this file as well. If we don't have this operator overloaded and come back to the test, and so now we notice this one doesn't even compile. It says no operator insertion match this operand. So which means, okay, I don't know how to display student 1. I don't know how to display student 1 because student 1 is a user-defined data type. So we're trying to teach this operator how to display student 1. Okay, how to do that? Let's see. Number one thing, this operator, it cannot be a member function because the left operand is cout or some other OStream object. It's not even this data object, so it cannot be a member function. It has to be a non-member function, but I give it some privilege. It's a friend function. A friend function means I'm not part of this class, but I'm a friend of this class, which means I have direct access to the private data member. So now let's take a look at the implementation here. So you see the implementation here as a friend. So you only declare friend in the header file. Here you don't have to say friend. Okay. You see it's not part of the class, so you don't need to say like data : that means you're part of the class. You're not part of the class, you're just some global function here, but you have friend privilege. So let's take a look at the friend privilege. Because you're a friend, you don't have to say a student.get PCCID. You can access the private data member of student object right away. That's what a friend function has. So we simply access a name and access a PCCID and the GPA and display it somehow. So that's this insertion operator overloading. So the OStream object and the student object, they're both the parameters. So you can see if I say cout S1, so essentially this function get invoked. So this is equivalent to operator, I'll just say operator here, operator less than, and cout. It's not easy to write using the mouse. Okay. So essentially this is equivalent to this one. Just invoke operator insertion and pass in cout object as the first parameter and S1 as the second parameter. Alright, so that's about this operator overloading, and now let's take a look at another one. And let's say this less than operator or equality operator. I overload them as non-member functions just to give you some example. They're not friends either, so they're just some global non-member functions and take two operands there. So let's take a look at the implementation. I'll use this less than operator as an example here. So because I'm not a friend, I have to go through the public interface like d1.getName, d2.getName, then compare those two names. I cannot just say d1.name because I'm not a friend and I'm not a member function. So when you have something like this in your code, like if, let's see, S1 is less than S2, something like this. So this one, if S1 is less than S2, if you don't overload this operator, this one won't even compile because the compiler has no idea how to compare those two objects. If you overload it, essentially this part, it's an invocation to operator less than S1, S2. So essentially this is a case. So it's like if invoke this function, operator less than S1 and S2. Alright, so that's about operator overloading. We go through this trouble because this makes our life easier later on when we focus on our data structure, when we try to organize data. For example, if you're trying to assign a data object into the third element of the array, you can just go ahead and use this assignment operator without even thinking about what's exactly inside of the data, what kind of attributes do they have. Are they dynamic memory or are they static memory? You don't have to worry about it. You just you can just use this assignment operator and assign that object to the third element of the array, or you're using a linked list, you just assign this one into the node. So it's much more convenient. And for debugging purpose, you can just say see out your object. You don't have to worry about exactly what am I seeing see out in. Is there any attributes I need to get? You just use this operator, because we put the logic about how to display these objects all in this operator overloading. Thank you.